All right, we're back with our circles here. Yeah, circle stuff. And on number 2, we're solving the circle circumference formula for pi. And yeah, there are 2 of them, but I am going to start with the pi times d formula. So on the right-hand side, I am solving it for, I'm going to highlight it in here, not with that color, it's getting magenta. We're solving it for pi. I'm going to get pi by itself, right? So pi is currently being multiplied times the diameter. So to get rid of the diameter, I will divide both sides by d. Okay. So on the left-hand side, both of these variables are different, so I leave it like that. And then on the right-hand side, the d and the d will cancel. D divided by d is 1, and it leaves me with pi. So take a look at this, would you? Pi is equal to the circumference divided by the diameter. And that's exactly what this statement says here. Pi is defined as the ratio of a circle's circumference to its diameter, which is exactly what we found by solving for pi in that circumference formula. And this is true for every single circle. If you were to accurately measure the circumference and accurately measure the diameter and divide those two, you're supposed to get pi. The problem is that you could never be accurate enough. There's no ruler, there's no tape measure that's so incredibly accurate that you can measure those two things on any given circle. Let's say it's this one, divide them and get the exact value for pi. So there's got to be some other methods that we use to come up with pi. And I don't know if you've ever considered or thought about it, like where did all those numbers come from? Like if we type in pi in the calculator here, let's get rid of all this garbage. And we hit that pi button, you hit enter on it, and it stops at just, I have no idea, that looks like it might be about 9 digits or something like that. And it stops right there, but it doesn't stop. It keeps going forever and ever. Have you ever considered or thought about like where those digits actually come from? At the end of this year, we will do a small little project where we come up with those digits using the same method that this Greek mathematician named Archimedes came up with a couple thousand years ago. He was a pretty smart guy, pretty smart. Okay, so let's now look at our final example, right? The formula for the area of a circle in terms of its circumference. So when I do a problem like this, remember how I've modeled it is, what formula are we writing, first of all? And that formula is for the area of a circle. So I'm going to stop right there because I want to write that down. Area formula for a circle is pi r squared. Okay, so far so good. And we want to write it in terms of, there we go again. We see those same 3 words, those same pesky 3 words, in terms of its circumference. Right now, the area formula is in terms of just its radius. I need to know the radius length in order to compute the area. But instead of there being an r there, we want there to be a circumference. Okay? So in terms of its circumference, I want to highlight that there. And so now I need to write down a circumference formula. But you know what? I've got 2 possibilities. I've got this one, or I have this one. Okay, so I need to make a decision which one of these am I going to use. Am I going to use the 2 times the r, or am I going to use the pi times the d? Well, the problem with the pi times the d is the fact that there's no d in this equation. I have to have a variable in order to substitute the other quantity into. And I just don't if I choose to use the pi times the diameter, which is enough to eliminate it for sure. And so I will use this one. They do have the same variable here. They both have an r. And that's the variable that I want to solve for in the circumference formula, that I can then put it into r in the area formula. And that will get rid of it. So that's what I'm going to do on the next step here. So in order to solve this circumference formula for r, I think about like what is the 2 pi doing to the r? Remember, we're treating the pi as if it is like a variable. It's going to be attached to this 2 here. And both of these things are being multiplied times the r. So to get rid of it, I'm going to divide it on both sides of the equation, okay? So divide both sides by 2 pi. Of course, on the right side, they will just cancel. And nothing is different. Or I should say everything is different on the left-hand side. Nothing is the same, and so nothing simplifies. I just write it down. Okay, and now I am going to take that quantity and substitute it in for R in my area formula right there. Okay, looks like I'm about out of room here, so I'll just scroll down a little bit. I'm going to rewrite my area formula here. Why am I using magenta? No, blue. Please keep it consistent. Pi, and I'm supposed to write an r there, but instead of r, we're going to write the quantity c over 2 pi, because that's what the radius is now equal to, and then I want to square it. Now I want to go ahead and clean this up just a little bit, shall we? So I'll bring my pi over. I'm going to square everything inside the parentheses. I'm going to square the top. It'll be a c squared. And square the bottom. I could have sworn we've done that before, haven't we? Didn't we have to? Yeah, we squared a 2 pi over here before, and we got a 4 pi squared. I knew we'd done it before. It looked familiar. Okay, and then just like I did before, again, right here, notice that I canceled a common factor of pi. I can do that once more. Cancel this pi with one of these factors of pi. Remember that pi squared is basically pi times pi, and I've gotten rid of one of them, but one of them still sticks around. And so my new area formula, area is equal to c squared divided by 4 pi. Now that formula should sort of look familiar because it's basically what I needed to use over here in question number 1. Remember that the circumference was 27. If we squared 27, we get that 729, that's right there, and then it's over 4 pi, and then it's over 4 pi. There you go. So here's, like if we had done this problem first, if we had this formula first, we could have gone straight to the answer with just a single step. And so that's the kind of usefulness of being able to do something like this. It also gives you some tremendous practice with algebra and going forward, having that kind of practice and that kind of confidence and being able to move things around, it's going to serve you well for sure. All right, so that's going to wrap up all of these different formula. So when we're in class, we will practice these different formulas in a bunch of different situations.